Thank you, Voss. Thank you very much. Good morning, everyone. I mean, it's morning for me here in the Bay Area, and um, and it's twice the holiday, right? So it's Labor Day here in the United States, and I'm Brazilian. It's Independence Day in Brazil, right? So I'm really breaking the rules being here, but it's something that I really enjoy. The Silicon Valley Innovation Center has been working together and bringing some good content and conversations, and that's my goal for this morning over here. What I want to bring is the context of all these technology evolutions or changes in how they can be applied to the digital transformation of the businesses, right? I am, as I mentioned, Brazilian. I was born in Rio de Janeiro, Brazil. I work in IT for a long time, based out of there. Had a long-standing relationship with local oil and gas and the market that was based out of there. One of the industries I have passion about, and how important they are for us, for the world. And also one of the most technology-driven industries. So I'm happy to have this conversation and discuss how we can apply everything that Silicon Valley has taught us into one of the key industries of the world. And finally, we do have a long slot, and I hope we can make it really productive through interaction. So if you want to ask a question, please use the chat. Vlas and the Silicon Valley Innovation Center team will be helping me address those. Or if you want to use the microphone and ask me between the slides, please do, right? I want to make sure you take most of the content I'll be bringing. So with that, right, why are we here today, right? We are here because there is this term, digital transformation, that is very hard to define, right? It could mean a lot of things, and sometimes it doesn't mean much. But most of the times it has been helping organizations become more effective, competitive, explore new revenue streams. And we're going to discuss the technology, process, organizational aspects of this trend and how it could be applied in infrastructure business, such as oil and gas manufacturing, right, where you wouldn't see this kind of e-business happening, right? Because it's still, oil's got to come out of the floor or the ocean, and you still have to refine it and make valuable goods, right? So it's very challenging to say, oh, I'm going digital. And finally, we have to address the 2020 situation. We are living in a very unique moment in history. And what we are seeing is that in some directions, businesses have been disrupted dramatically, right? And I'm not here as the industry expert. I'm familiar with the industry, but we just had a critical event early in the year, right in the beginning of the pandemic, when the oil barrel became negative price, right? How disruptive is that? And what the message is that we need to be prepared to respond with greater speed to challenges in the 21st century, right? And how can we be prepared for these situations? So with that, welcome to the Silicon Valley, right? The birthplace of the Digital Natives Organization. So like I said, the goal of this conversation is not to explain how we're going to become Google or Netflix, right? The goal of this conversation is to help you understand the fundamentals of these innovative engine that these digital natives company have brought together, and discuss how an existing organization could apply those to their benefit. Basically, we're trying to understand the wave two, right? Wave two and on. How some organizations realized that they were facing different forces, a competitive or a risk of disruption, or just the sheer evolution of the platforms that they could leverage. And they put it to work to their favor to become differentiated. it doesn't become as disruptive as this. So I don't know if you remember this image. It went out, it happened last year, 2019, right? So Elon Musk was launching a SpaceX, and they did a very funny campaign. So Tesla put their coupe car with the spaceman dummy, right? And it's now somewhere in orbit. And you know, this picture was emblematic, and it went all over the news, right? And we could be talking here about how Tesla is disrupting automotive, how they are more valuable than, you know, all other competitors. You know, many of them are over 100-year-old organization. What is happening? So I wanted to give the words to an expert of this industry to discuss what is happening. So the CEO in Volkswagen, right, when asked about, you know, what he saw as a threat, right, in Tesla, he basically provided this quote. And I wanted you to take a look at this, read, and we can do a brief comment in 1 minute. And I left the link too, so I can share the deck and you have access to this article, very interesting. But let me give you some hints of what we're going to talk about. What Herbert is talking about is that, you know, it's not about an electric car, right? Because even most Volkswagen, right, they build electric cars. It's not that. It's talking about an engine that continuously gathers data, and every 14 days, which is of course a very short window of time for an industry, you know, that needs to manufacture the products they sell, right? But every 14 days, their customers get a better experience. This is not what happens in, you know, in a car industry or in any manufacturing industry normally, right? Usually when you invest in something, in a machinery, or when you create a final product and you put it out in the market, it starts to lose value because it starts to age, and then you need to, you know, put the operational costs into consideration, right? And Herbert is observing that his competitor is not delivering an experience like that. It's delivering an entire different experience. And this experience is fueled by, you know, data, right? So more and more data generating ideas and insights, but not only ideas and insights, because idea and insights is, you know, just something in the air. But these are put to use in an existing platform every 14 days, right? So it's a fast cycle to innovate. And that platform, right, as you can understand, it's a digital platform more than a car, right? It adds capabilities every 14 days. So this is an example of, you know, how a platform that is digital is different and deliver value incrementally. And what we want to do is to make sure that every business can get some of these attributes, can execute on some of the ideas to be more and more competitive in the 21st century. But digital transformation, you know, can be as simple as pizza, right? So I love this use case, very emblematic, right? So we could be thinking about, you know, the fintechs, or we could be thinking about self-driven cars. We could be thinking about, of course, we're going to discuss, you know, what is influencing oil and gas and manufacturing, right? But it can be as simple as the Domino's Pizza case. So 2 years ago, when this article was published, the Domino's Pizza stock valuation was actually bigger than the largest tech companies, right? I'm not sure it remains real right now because of the trends we're seeing in the world, but still, you know, because what they did was to apply a lot of data to delivery, and we are living at home, right? Maybe it could be still true, right? I didn't double check, but moral of the story, you know, this company was able to differentiate against competitor, experiment accelerated growth in a business that is not exciting as delivering pizza. Why? Well, because they use the same attributes that Tesla was using. They were channeling data to insights to improve their capabilities and deliver a superior experience to their users and customers, right, with a much faster pace. So this is digital transformation in a nutshell. It's going to have different aspects. It's going to look different for each organization. But there are a lot of things in common. There are a lot of processes, there are a lot of approaches that we are seeing, and many of those started here in the Silicon Valley, and they can be applied to your business.
Rodrigo,
So, sure.
Quick question for you. So, I actually checked the stock of Domino when it was $10 in 2010, and right now it's 381. So pretty much the progress is still lived through the pandemic, and in fact, it actually in the beginning of the pandemic it was $100 less. But the question for you, so we talked about the differentiating to our customers, right? Differentiating to end consumer. But what about the businesses where we have a more commodity, right? Again, oil and gas, when we have some manufacturing, when we have some steel. What do you think are some differentiators there if you cannot truly, change the experience of consuming the oil as you would do with the car or you would do with the pizza?
Perfect. Great question, right? So yeah, I think I was talking in the beginning that it's, in the B2C world, it's much easier to situate the aspects of digital transformation. But, what we are seeing is that organizations that are applying these principles, even though they are discrete manufacturers and their products still are, non-consumer goods, they are industrialized goods. It's oil, it's refined materials, it is pieces and parts, right? What they're doing is that they're applying this to achieve dramatic reduction in operational costs, greater profitability, but more important, the ability to pivot fast, the ability to adapt their supply chain, their logistics, their distribution, their health of their business to an environment that changed much faster today than ever, right? So this is the key benefit and the examples we're going to talk about, right? So even though their end product and the way they deliver still needs to be, very much standardized, right? Because that's the supply chain your business is part of, right? You can do it from a much healthier business perspective by applying these principles.
Thank you.
Awesome. All right. So like I said, there are some patterns that are in common, and I created this idea of the 6 unspoken laws that govern digital transformation, right? And this is just a way to illustrate, how processes and people before technology are key for jumping into the journey. The first one is, of course, Murphy's Law. And I could enunciate here Murphy's Law, right? That anything that can go wrong will go wrong. But I decided to bring the interstellar point of view to Murphy's Law, right? It doesn't mean that things bad happen, they just happen, right? And this is 2020, right? You can look at, everything that is happening as, okay, these are forces and they are shaping us, how do I react, right? So Murphy's Law, be prepared for an environment that changes very fast because anything can happen and affect my business. The question is, can I measure it? Can I respond really fast? The second law is, well, it's native to the Silicon Valley, right? It was established by Gordon Moore, CEO and founder of Intel, right? And it's about the speed of processing, right? Since the 60s, when this law was formulated, compute power has been accelerating and growing, and it has been delivering creative uses of technology that the business cannot ignore. We're going to talk about today ways to make these uses, to the benefit of the business. The third law is called the Conway's Law. We're going to talk about how do we apply this technology, and the key to this transformation, I'm going to bring in advanced software, right? The aspect that made Silicon Valley unique, software, right? And how do I turn a car into a digital platform? It's software, right? And software needs to be built to scale beyond human touch, human control. right? I need to operate thousands of elements and sensors with greater efficiency before needing thousands of people, thousands of professionals. So we're going to talk about how do I scale a business by running it with a strong foundation of software. And the challenge here is that in order for organizations to build software that scales, right, it needs to address their complex organization, because organizations will design systems that copy the organization. So we're going to talk about reorg and restructure in some cases. There's another law, right, that of course, in order to put this innovation to work, we're going to have an environment of transformation and put projects in place or programs in place, right? And, one of these laws is the Brooks Law about the complexity of networks, communication and collaboration, right? So here is what it says: adding more people to a late project only makes it later, right? So we're going to talk about organization again. We're going to talk about thinking about a team for innovators and the capabilities they should have, but also how this team should look like. We're going to talk about Goodhart's Law, right? Which is, how do I make a business go and I drive the innovation necessary, right? So this business go is, of course, needs to be measured, but the measure can't be the target, right? It's a game of incentives. So we're going to talk about how incentives play a role into this transformation, right? And of course, Dilbert is a very simple way to explain incentives and bad behavior, and that's exactly what Goodhart's Law is about, right? If you give me a bad incentive, I will generate something that is not good for my business. So we're always going to talk about OKRs and how do I make my business respond, right, to the right incentives.
Rodrigo, there is a quick question about could you explain the Brooks Law with some examples, and then I give an example for the Goodhart's Law.
Perfect. So Brooks Law is also an organization. We're going to talk about the way Silicon Valley builds their own company organizations and how they're going to be applied to organizations, trying to incorporate these practices. But the idea is that in a team, in a group, it's better to have small cells that can move in parallel, like special forces units, right? Because these units are going to have cohesion. They're going to have the ability to move forward faster and in agreement, right? So, and if I need, okay, now this program is gaining momentum, I need to scale it, decide between, growing the team to a point that I still can have healthy communication, or, right, expanding this into more units, grow cell by cell, right? And communicates again back to Conway's, right? So this idea of these small special forces units is also paired with this over here.
Yeah, and I can also, from my experience, I can say that kind of like Brooks Law, it has a very interesting kind of toll that it takes. I call the transactional costs, and that's something that is almost like killing the software outsource. When you have coders that do not understand your business problem, they do not understand your business, you need to pretty much build the layers between the people who actually build something and the business case, right? And every time you add additional person in this transactional, it's almost like this broken telephone children game, when like with every person, you're just losing some kind of information, you're losing some kind of understanding, and it is not really solved by adding more people. So it's actually, the more people you add, the more information you lose in general, right? So I think that's kind of how I like to see the Brooks Law.
Great, exactly that, right? The approach that, okay, now you add more people to my project, I need to train them, I need to bring them context, right? I need to update more people. So that's exactly what's happening, and we're going to talk about how Silicon Valley and modern software has overcome this challenge. And finally, the last law is Metcalfe's law, right? And it was created in the communications industry. right? But it's about the value of, incremental touch points and connectivity. So we're going to explore this as we talk about going from physical systems to digital platforms, right? And how we can apply this to things like Internet of Things, right? And make discrete industries become more and more digital, right? Or going back to the Tesla examples, right? It's a fleet of 500,000 nodes in a narrow network, but inside each node, which is a car, they are loaded with connected touch points, sensors, and these make the platform really, really valuable because they bring insights over and over, the ability to understand better the environment and improve on my models and simulations, things that oil and gas understand very well. So upon those laws, right, that govern digital transformation, I'm going to talk about these two major forces that drive the digital transformation. I'm going to talk about data and software, right? And I'm going to start with data because that's where most of the ideas come from. So if anyone asks about how do I start a program like this, right? The answer is ask your data. Look into the pool of information you generate and try to formulate ideas with the what if mindset, right? Or what might mindset. What might explain? What might happen if I knew this in advance? How could I have an idea of this could or not affect my business, right? So data is usually where I recommend we begin a digital transformation journey, right? Many catchphrases have been written or said about data. Data is the new oil, right? I don't think it is the new oil. I think it's, forgive me for, you're the industry practitioners, but data is better than oil because it doesn't deplete. You're going to reutilize that, right? You're going to use it over and over and put it into more use cases. So it's a little unlike oil. And now it's the perfect time. Why? Well, because we bring this digitization of everything, right? We are able to put a signal and understand what is happening, right? Everything is generating data from the mobile device to the sensor in my pipe, right? Combined with basically infinite compute power, right? At a viable cost. So 50 years ago, when we started talking about artificial intelligence in the academia, it was pretty much theory. You couldn't put it to practice, right? Because it was too expensive. You needed to be, a government institution, or you needed to be a university with a supercomputer at hand, right? And now the power to run this is at reach. And of course, oil and gas is one of the industries that have most high performance computing infrastructure available in the world today or invested on today, right? Dealing with simulations and model is no stranger to the industry. That's how the industry does exploration and in production for over years, right? So the trend is already there. What is the difference now? The difference is that we are now able to aggregate more and more data, business data, real-time data together with production data. And also, we're able to get those insights at a much faster speed, right? So an exploration job, trying to get, from raw seismic data into an insight about a well, right? It used to be something that would run for days in high performance compute. And now with Moore's law, right, it could be running for hours. But more than that, I could be using the same kind of infrastructure and knowledge that I have to run a business simulation and try to understand what the business could look like if the trends in consumption are changing, if the market outlook is changing, if something comes in a given market and disrupts the way people buy gas and other oil products, right? You can do a lot of what ifs and what might happen if. And the power of might is the power of analytics.
Rodrigo, a quick question for you, and I think that in terms of data and just aggregation. So as you said, and that the more kind of nodes you add to your network, the more information you get, and the more value you get out of it. But sometimes, and especially because of the Moore's law, the data generated is almost faster than we can analyze it. And especially, when we, for example, when we start the project, and when we get to the very end of the project, and we realize, oh God, I wish we were collecting this data earlier, right? So how do you actually address this problem that there could be so much data generated across your sensors, across your software, across your sites, and then your ability to analyze it, not in terms of compute power, but just because in terms of how many developers you have, how many data scientists, how many business analysts you have that can actually make sense out of this data. So how do you balance this plethora of data, almost like unlimited data and limited resources to analyze it?
True, right? So today the traditional analytics or business intelligence model is looking at the past, right? It's like us gazing into space and we only see an image of billions of years ago from the stars. It's pretty much what's happening in business today. We're looking at a rear view mirror. It already passed, and the best we can do is try to understand how it could affect my business. So the whole industry is shifting to what we're calling real-time analytics, right? And what we're trying to do is not only to have all these sensors feed my ability to see, but also have the ability to reason in real time with what they see. So what we're going to talk about in terms of trends, when I get to that in the presentation, are all the efforts that the industry is doing, all the efforts that are happening to bring action as close as possible to the business advance. That meaning to the pipeline, to the pump, to the refinery operations. That's the goal. So today, right, we capture this data, we spend some time transferring it, transforming it, loading it where I can process it. And then maybe a couple of days after, 1 week after, I have insights of what happened 1 week ago. And then I, as a decision maker, make a decision about, all right, so it happened 1 week ago. I learned from this, right? I'm going to improve these and these aspects of my business. This is what's happening today. The whole transformation is to make my business, my production chain, run like a Formula One car, right? So yesterday, Italian GP, very exciting, right? What is the word of Formula One today? Telemetry. They are not analyzing what happened during the race, after the race. They're analyzing lap by lap in real time, right? So they say, hey, Lewis, slow down, tires are burning, right? This is what we want to accomplish for manufacturing in an industry like oil and gas, that you are able in real time to make decisions to win the race, right? And the key to that is to turn your analytics into real-time analytics. We're going to talk about how we get there. That's exactly the goal of this conversation here, right? But we are benefiting from algorithms, right? They are available in theory. Supercharged compute, financially viable now, and massive amounts of data. What do we need to make it work? We need an engine that understands business problems and turns into business solutions through data analytics, right? We need a team with the expertise to first, understand the goals of the business. That's the business problem. And then gather the data and experiment on the data, makes the what if or what might questions to the data and find a solution. And of course, we need to put the solution into work. And what we learned is that this process in the middle is actually an interactive process. It's an innovation engine. It is experimentation. It is, as we call, data science. And like science, right, it is a risky activity. I may not get out with the best answer for my first essay. I will realize that, okay, this correlation is not good. I need to run it again. Thus, the birth of this discipline called data science. It's the act of experimenting on information to try to explain the world, right, using modern technologies to accelerate the cycle. And the good news is that, once put to practice, data science really delivers. Data scientists, right, according to Harvard Business Review, is the sexiest job of the 21st century and still is. So my ask right now is that, take a look into your organization and try to figure out where you're going to find the pool of expertise or the talent to build a center of excellence for data science. That's probably where your digital transformation engine is going to begin. That's probably is going to be the cradle, the safe environment where your ideas for productivity and disruption are going to come from. There's a lot written about data science. There are some theories about what a data scientist is, but basically it's a team. It's not a person, right? It's getting harder and harder to find the superhero that knows everything, that knows math, statistics, Python, high performance compute infrastructure, and can code everything, right? It's a team. And it's basically how, all those laws that I gave are applied into creating this team that drives digital innovation. So we're going to go back to that. Who is the enemy of the data scientist? It's the hippo.
Rodrigo, I just want to quickly add on this that on your thought that about the team, right? I also think that a lot of people, when they start doing this exercise, they think that the data science should be some kind of IT job, or data is IT or operations position. But in reality, especially in the asset heavy business such as oil and gas or manufacturing, that the engineers who are on site, who monitor those machines day in and days out, are the essential part of this data science team. Because unless there are data scientists, they can understand the business, they can understand the problem, but they could not, as you said, they could not understand operation, they could not understand every machine going in and out. So that team is really not something that you can build on top of your organization. It's something that has to be interweaved on every step, starting from putting the sensors in some kind of machinery all the way to the executive report.
Perfect. This cross-functional team. And this cross-functional team is going to have one enemy, the hippo, right? And the hippo is an acronym that, the data science movement created. It means the highest paid person's opinion. So here's the thing. Sometimes the insights this team is going to uncover will challenge the status quo. And status quo is going to say, oh, in my experience, in my 35 years of experience in this business, that's how it works, right? This is the hippo. And become data-driven and accepting the insights that data bring to drive key decisions is one of the disciplines that need to take in place when we manage through a digital transformation, right? So just wanted to bring this interesting acronym.
Yeah,
HIPPO also means highest paid persons in the office.
I also call this approach "trust me, bro" approach. But we have a question, and maybe you'll be talking about it later. How do you suggest to start promoting a data-driven organization?
Perfect question. I will talk about this, right? But it needs to be a center of excellence approach, right? So we need to create this lab of ideas, this environment where it's safer to experiment, right? And I know that it's hard because you'll be pulling people out of operations, or but this is this is like doing your own VC inside your own organization. Talking about Silicon Valley, right? Creating this environment that can experiment a little and change the mindset, and this environment can then start proving by insights and validation with quick wins, right, how this new model could be applied. And of course, it's not easy, right? It's much easier saying than executing. And that's why a lot of these digital programs fail. We're going to talk here until the end of the conversation, how to make it safer, how to minimize failures, right? How to overcome known challenges and go over them as fast as possible.
I also want to add that we have another question here that says, is this to say that you mean data science not as an IT function, but the analytic capability of each level operation management that generates the data and also analyzes to get insights? And I'm just going to start kind of with my own opinion and just bridge it back to what you just said, is that yes, I absolutely think that every step need to understand how data is generated, how it's used, and how it's being processed, right? And especially processed from step to step. And that, Ronald, goes back to your question, is that pretty much the only way you can promote this data-driven organization in this very small piles. And then usually when you come to, again, to the operations, to the management, to the like manufacturing lines, usually when you talk to people, they will be able to tell, oh, you know, like if I could analyze this, only if I could analyze that. You would not be able to just come to say, now we're a data-driven organization, and then everyone is. You need to really start, and I'm going to talk a little bit more about in my presentation later today, but you really need to show the personal profit, the personal benefit for a particular organizational unit, for the organizational BU, for them to actually embrace it. If it does not generate anything but kind of nuisance for them, you'll never be able to onboard it. And that's why, again, when you're just trying to do a data science group that just kind of sits on top of everything and just goes and bothers everyone just trying to collect data and benefit for themselves, it's never going to be a successful exercise. So that's why it is important. And again, Rodrigo, I don't know if you agree or not, that you need to really pretty much like bribe every person involved in this chain with their own benefit that they will get from this like data-driven organizational stability.
Correct. It can't be disconnected from the business. You need to have buy-in, and it needs to be sold internally. And the best way to do it is to recruit right in the beginning. Figure out the use cases. So that's what I'm going to talk about next, the use cases, right? So every organization in every industry has challenges known to operations, right? As Vlas was saying, right? A business operation expert could be saying, oh, if only I could analyze that. Build a list in your business of those use cases you want to address, of those problems you want to solve. And look for those that are viable. Look for those that are, you know, sorry, it's you know, cliche, but it's the low-hanging fruit for a quick win, right? So, for instance, when we talk here about energy, right? There are many use cases that can be addressed with data. And the good news is that when I combine the business expert with the data scientist, right? The business expert has the business context, and the data science has the algorithm and the data response to those. So look how powerful does it look when I put them together. For a data scientist, these different problems highlighted are the same, right? They look very different from a use case and business perspective. And they even look different inside their own domain, their own industry vertical area. But for a data scientist that understands data points and modeling, right, an approach to find commonalities or exceptions very fast using artificial intelligence, right, using machine learning techniques, they are solved in a very similar way, right? So this is the beauty of AI, is that it translates business context into algorithms and models. And this is why Vlas was talking about, and I was talking about the need of this multidisciplinary team, because we need some people that have deep expertise in the statistics and modeling, right? And they were probably more horizontal, And if they worked alone, they would never be able to explain the problem in the business context. And you need to pull in the people that know the business context, the people from the business operations, and make them part of the solution. Because then they can bring their own context, right? And combine with the expertise of these other part of the team and make ends meet, right? So for instance, if you're talking about oil production optimization over here, right? What we are trying to find, we're trying to find time series of data points and try to identify which combination of thousands of variables of data points provide the optimal output, right? This is the function. This is the math function. And a statistician, right, or a data science expert can find this function, but only if he is considering what is optimal. And the only person that can tell them what is optimal is the people that have the business context. All right, put this team together is the challenge, of course, right? And recruiting, developing, retaining these experts is a challenge even in the Silicon Valley. They are the sexiest job of the 21st century. So start looking into your organization and figure out where you have this talent, you know, who you could be reskilling and training, or partner with education institutions, right? A little background. So when I was in Brazil, my company built an R&D center inside the Federal University campus. We had around 30 researchers and other 30 students in partnership with us. And we are doing innovation focused on oil and gas, right? So University of Rio de Janeiro is where Petrobras has a big R&D center. We were there because we wanted to partner with them, right? So that was one way that we tried to address the skill problem.
Really, a quick question for you. So on that collaboration, right? And I touched it in my presentation, but since you're talking about it, so do you think that in general that companies, when they share their data and when they're trying to kind of monetize this data, even with academic universities, it is, so to speak, make them cheaper? So meaning that if they give the data to those researchers, the research itself is actually becomes cheaper because researchers understand the price of the data, and therefore it's kind of like a mutually symbiotic relationship that decreases the costs because the data is provided. Is it true? Is it true in your case, or how it was?
There is one truth that is, you know, it's how you build an agreement, right? Because once again, we're going to talk about goals, and the goal of the business is to get an outcome, right? The goal of the education institution is to get, you know, the visibility, the publications, or the innovation. And the goal of the researchers is, you know, the patent, the IP, right? Everybody has goals, and it's how you make it work that everyone wins in this situation. And finally, about sharing the data, right? There's a lot of regulation, especially in oil and gas. So, you know, most of the times data is not actually shared, right? It's just that the work takes place in local, or of course, now that we are all at home, in a very controlled environment because we're not actually sharing, right? It's a challenge that we see, especially in highly regulated institutions. And by the way, that was one of the reasons why, you know, we had to build an R&D center inside the Federal University campus, neighbor to the Petrobras R&D center. Because if we wanted to access the data, we needed to be with them, right? So I think that it's not that the cheaper is a very I'm trying to find the adjective here, but it's not cheaper, right? But it is convenient because then everyone can win, right? And maybe with that in mind, we can say cheaper. Yeah, it's affordable. It's affordable to execute like this. So we talked about becoming data-driven. We talked about finding those skills and enhancing your team. We talked about how they are a team, right, rather than a superhero individual, right? But now we're going to talk about the second part. How do we put that insight into execution? And that's the art of the Silicon Valley. So remember the Tesla story that Herbert, the CEO of Volkswagen, was telling them. It's not that just, you have 500,000 platforms generating data. It's how you make it, you make a deployment every 14 days. How do you put into production for the Tesla car owner every 14 days? It is the last mile gap problem. How do I scale and put in production those insights faster, responding faster to the business, right? Responding faster to the external environment. How do I make my organization become more agile? And that's when we combine the world of data science with the world of software development, but actually modern software development. Organizations like, traditional oil and gas companies do have strong software development teams, right? You have been doing software development for years. You developed when you deployed your ERPs, when you deployed your business systems, right? But here, what we're going to talk about is how Silicon Valley does development and why organizations should also consider incorporating those capabilities into your portfolio. And the key word for that is agile, right? Agile meaning, the ability to execute things a lot faster. And the key is not because I want to get to the outcome really soon. The key is that if I'm deploying very fast, I can change directions at any time, right? It's like instead of doing an 18-month capital project like drilling a hole in the ground, right? And I'm only going to start experimenting the outcome here at the end of my project. Software could be done in very small cycles that allows me to adapt and review priorities and change every time I finish a cycle. That's agility, right? And that's how Silicon Valley does the products that they do, right? Very simple way to understand, right? Compare the, 5-year long, well production project versus Instagram, right? Instagram came up as an application with, photo sharing and 5 filters you could apply. And 1 week after, you had 10 filters. And 3 weeks after, you had the like button, right? So that kind of incremental and fast changing ability that is native to software becomes another tool in the belt of an organization like yours, right? Of course, you will continue to have to do your, modeling and 5-year plan for drilling a well, right? This is the nature of oil and gas business, but your ability to combine that with quick insights and prediction and change. And when you look at your portfolio of production, right, you look at different time frames and you can think faster at each moment. That's the ability that, a modern software development mindset can bring. And this modern software development has given birth to the software renaissance we're living in. So because software has become so key for the digital world, right? Developers are now, highly valued professionals as well. And that team that I talked about, the data-driven team, it has a strong component of software development as part of it. So it's actually not just business and data scientists. It's business, data science, and developers together. And the data scientist is a developer. And by the way, more and more, the business person that can code, right? And there are some platforms that make it easier right now, right? You don't need to be like a software engineer. There are some higher level programming capabilities that can be applied. It makes you more valuable. It makes you more digital, right? So this is the software renaissance. The fact that software is becoming the business platform is driving more and more attention into the power of software to transform business. And this is spurring very creative approaches to software development and software technologies and software platform. We call this the Cambrian explosion. right? And if you are in oil and gas, you know what Cambrian is, right? The age of the history of Earth, right? Where life experimented. We had gone through a major extinction, and it gave a lot of opportunities and niches for life to take different approaches, right? And that's when you had all these weird life forms. Same thing is happening in software. Open source and communities are driving more and more platforms that continue to evolve and become more efficient, and make sure that you are honing a team and you are growing a team that is able to tackle software in modern ways.
Rodrigo, and if I could make on this and just kind of from your experience again, what I have noticed is that probably one of the most successful organizations, the way they do it is that pretty much software engineers are focused on making sure that the data quality and the data processes are correct, right? So like there is also this concept of the data warehouse where all the data is stored in the right way and all of this. And then from the business perspective, you said with the software renaissance is that there are tools, such as Tableau, Click, Domo, all of those, that really just shifts the focus to the business people to be able to interpret that. And therefore, kind of like the software reporting sort of considered to be a big no-no right now, because why would you allocate your software engineers to do some kind of reporting when what you need to do is just to make sure that you get the data, and then this data could be manipulated in any way possible depending on the business case. So is it something that you kind of see this sort of separation of making sure data is correct and then interpreting the data on the business side, or do you see something different?
There's a little more than that. This is a key component because you're now empowering decision makers with data visualization and data insights, right? But there's also the ability to put software on your business value chain, right? So for instance, making your pipeline automated with software, making your production refining automated with software, right? So there's software in more places than just the business analytics, but the business analytics is a great example, right? And because of this idea that software is going to be everywhere, is that we need to understand the power of the software renaissance and understand that developers are the new kingmakers. So I'm going to comment here about how this new modern software is done here in the Silicon Valley, and it's going to connect a lot with what the data science is, right? Like I said, a data science approach with an agility of delivery is the engine that accelerates Silicon Valley. So same as I talked that data science is a team effort, modern software it also is, and actually the teams become interlaced. Every time we think about developers, in the past, we would think about a lonely person in the corner of the office talking to the computer and not talking to anybody else, that has lunch in different moments of the day. That couldn't be further away from truth in the Silicon Valley at all, right? Software is collaborative, right? Just like because it needs this multidisciplinary approach, it needs business context, it needs business value. Right? But also, because of the agile mindset, people need to be checking at each other frequently if they are doing the right thing for the business according to the right metrics, right? So it goes again to the positive metrics that we are delivering. So you're going to see things like, in an agile methodology, things like stand-up meetings. Every day, this group, not a big group, remember the communication lines. This is a small team working on a business function, gets together and checks eye in the eye, what are they doing? And if someone is falling behind because they are facing a problem, right? It comes up every day, not at the end of a delivery cycle, not 3 months from now, that when you have to integrate everything and you realize, oh, that module didn't happen. In the Silicon Valley way, every day they're talking to each other and saying, hey, how is our thing going? Oh, my test just finished. We are good to deploy that. Or, hey, my test is failing. I need an extra eye, right? So people get together and work to make sure that the goal the incentive that drives that entire team, that small unit, is moving forward in the right direction. It's collaborative. Sometimes it's loud, right? It can be as drastic as one thing called pair programming, right? In the Silicon Valley, developers sit side by side with each other, and they actually share the same computer, right? And they code together at the same time. And of course, with the pandemic, everybody now at home, they're doing this on Zoom, right? I had conversations with a few colleagues, and here in our briefing program, we have conversations with these professionals, but they need to collaborate more than that.
Rodrigo, we have a question. So, what do you think about making a proprietary team for the first stage, or is it better to outsource? So, for example, when you're just trying to maybe do something or just kind of do the pilot project, is it better to do it in-house, or is it better to outsource?
I would say that for the digital transformation, never outsource. Never let a company, a partner, an integrator do the digital transformation for you.
Consultants.
Yes. Don't let them do this for you. Do it together, right? So what you need to look for are partners, integrators, and experts that want to be part of this first team with you. Maybe you have, you were able to recruit inside your organization 5 people with the skills to lead this first initiative for a set, a group of business problems, right? Talk with your partner, your consultant, and they're going to bring another 5 or 4, and you're going to build this first hybrid team. And as you are working together and you see how close they work together, right? Your professionals are going to learn how to do it. And maybe the next time, or maybe the next cell is going to be built entirely with your team members. But the way of working it, right? You learned it. So don't outsource it, but it's very, very recommended that you partner with those practitioners, those that know, right? And there you go again. So what is this? Well, this is the organization law applied to digital transformation. In the Silicon Valley, they call it the 2 pizza teams rule. Actually, it wasn't Silicon Valley, it was Seattle, because it was invented at Amazon. So in Amazon, right, the way they keep the communication lines healthy is that they have this rule that if a team has grown to the point that they need more than 2 pizzas to be fed, if they are doing working lunch, the team is too big. So they call it the 2 pizza teams, right? And that's how they keep the law of organization, this cell, at a healthy moment, and they have great communications. And once again, all these new way of delivering value and collaborating and coding, they have a business enemy, right? And the enemy of agility is from the Mandalorian. This is the way. Is when you face a wall that says, hey, now I need to put this code to run in production because I'm moving fast, right? And there's going to be a process that says, hey, we don't do this here in the company. We don't put things you just developed in production without, staging this for 90 days and testing it over and over. No, but it was developed in a different way. Sorry, but this is the way, right? And the answer to it is the discipline that comes together with agile development. And it's called, here in the Silicon Valley, DevOps, right? And DevOps is when you take also that multidisciplinary team that has business context, analytics capabilities, software development. And now you have the last component. And the last component is the ability to run it in production. Ops, you have operations. In Amazon, there is a rule. You build it, you run it. You're not outsourcing support, right? You're taking the code you developed and you're putting to run because you developed it right, you tested it as you developed it, you did it collaborative. It's not being backed by one individual that knows it all, it's being backed by a team. And now this team has to run it. So the degree of commitment about the quality of the digital product is very, very high. That's DevOps. And as you can see, as you can imagine, it changed completely the business and the IT organization, how they are mapping. And that's the art behind the digital transformation. That's why I talked about the 6 unspoken laws that govern digital transformation. Because in the end, technology is not the barrier of execution. It is people and processes. It is thinking different. It's to start building a cell that looks more like a Silicon Valley organization than a traditional siloed, vertical optimized kind of organization. And that's the hard part.
Yeah, and I wanted to add on that part, and I think you already heard me saying that. But like back at Goldman Sachs, when I was running my team, that it was we've been doing exactly this. When you are a strategist, or when you create some kind of algorithm for trading, you just go in, you test it with your business partners. You pretty much the second line of defense when something goes wrong. And what it gives you is that when you don't have those kind of like separate, QA people and then test people and then UAT people and all those wonderful words, what it actually gives you is that this understanding of business that you mentioned earlier, is that if you take your software every step along the way and kind of just making sure that whatever you do aligns well with QA's environment, UAT environment, business environment, production environment, your knowledge and understanding of business and ecosystem just grows exponentially because you have to do it every day, and therefore it creates unique opportunities for creating better products just because you know pretty much everything that goes into that ecosystem.
Perfect. And if you want to understand how it looks in real life before experimenting this in real life, I recommend this book, The Unicorn Project. It's not a technology essay, it's a novel, right? So it's told with characters and drama and organizational challenges and politics, but it's a story of how an organization, it's an auto parts company, right? How a team of developers that call themselves the Rebellion decided to start something that became the digital transformation of the organization. And it talks exactly about that, about the frustration of the engineers, because the business operators, the sellers on the stores were not getting value from the technology. And the developers were feeling they were not able to bring the innovation they wanted, right? And because they had all these organizational challenges, and then they decided to create kind of an unit that played rogue against those rules. And as they started to deliver, they became the engine. They started attracting, right, rather than breaking. And how the company then embraced their story, right? Oh, okay, I got it to the end of the book, but how it happens is really the art, right? And describes every step that Vlas was saying about his challenge running an innovation team in his organization. And finally, where do I run this software, right? Software that is built and updated quickly and is driving innovation very fast needs an infrastructure that is equally agile, right? And the infrastructure for that is something that you're going to hear over and over here in the Silicon Valley. It is the cloud. And behold, the cloud, right? So of course, I'm joking here with Larry Ellison. He's a key person here in the Silicon Valley, CEO of Oracle. But over 10 years ago now, 2009, he said this very interesting phrase that just sounds weird today, right? And it's somewhat true. But the fact is that, technology infrastructure also is being modernized by these modern ways that businesses are doing their digital transformations. And cloud for us is what we call an operating model. It's not about where, right? I'm not here talking about oh, put your IT to run at Amazon data center, Google data center, right? Especially in oil and gas, you have data sovereignty. You're operating in places where latency is a challenge, right? Where, not only your computer shouldn't be, but also you don't want to be there, right? So oil and gas is very exciting because it's challenging your IT deployment operations in so many ways. In what we talk here, because then I'm technology in the end, right? What we're talking here is what we call a hybrid approach to the infrastructure. Basically, you need to put technology in more places. You need to put technologies in more data centers. You need to put technology at the edge, close as possible to the business events, right? Because you are instrumenting, you are reasoning more, and you're trying to take action powered by software. So cloud for us is an operational model that is optimal for software that needs to be updated frequently. And here are the flavors. I would love to continue this conversation with your IT teams. That's actually my passion and specialty.
I just want to add from here that I think a couple things here. I think the first is really interesting is that private cloud concept, because when the cloud was just born, sort of like in the late 2000s and early teens, is that it was really not considered to be safe, so to speak, right? It was considered to be public, and companies were very worried about their data going in. But as the time passed, obviously, that people started to create solutions, and right now, pretty much every kind of the cloud providers, be it Oracle, Amazon, Azure, they all create a certain ways that you can safely buy this compute power, buy this cloud inside your organization. So all of those issues that were initially stopping companies to actually doing this sort of like private cloud and not on-prem, not on premises computation has been solved since then. And that's, I think a lot of people are still thinking that it's like the state of the world 10 years ago. And then the other part, I think the edge is extremely important. And I think we see it over and over again in all the applications, is that edge is something that truly revolutionized your ability to look into the data. Because pretty much, let's say if we are talking about some kind of remote platform somewhere in the middle of the sea, right? By the time the data gets to your center somewhere onshore, like it's too late, right? And that's why this edge computing, trying to aggregate this data, trying to analyze this data on the location as close as possible to the decision making and the data gathering, becomes extremely important. Not only then you process this data to your kind of central location where the speed and the size of the pipe is of the less importance.
Exactly. And like I said, oil and gas has been living at the edge, right? You have been challenging IT deployments for years, and it will continue to happen as technology becomes more exciting and more of a critical piece for the digital future of organizations. And I'm getting to the end of the technology talk, right? I just want to discuss how we bring it all together that Blas and I were talking about, right? So the first one is IoT, meaning the Internet of Things, right? And it's about the sensors we put or the digital twins we create, right? Or it could be your pipelines, it could be your oil platforms in the ocean, right? So I work with Petrobras, they did, deep ocean water exploration. Everything was disconnected or poorly connected most of the time, right? Because of the distances that we were, and the latency was a huge challenge, right? But in the end, right, because everything was already instrumented and there was a lot of intelligence on board, right? The experience, the ability to monitor in real time and take decisions for productivity and security and safety, right, were still there, right? So it could be told that IoT was enabling a very, very productive operation. But we're excited that, maybe in the near future, the world is going to be even more connected with 5G, right? And this is going to mean a lot for multiple industries. We're excited about this idea, of a world that is today is poorly connected, doesn't allow a lot of fast transfers, and maybe it's going to become more. But still, you know, just like Vlas was talking about, there's so much data that needs to be reasoned in so much time, and the speed of light is actually not that fast, right? It's time to respond, right? When you are, you know, doing a self-driven car, when you are fine-tuning, you know, a heavy equipment with consequences, you don't want to wait a millisecond for data to travel to a remote data center until an answer comes back, right? You need to have that answer as soon as possible and in place. And that's what being at the edge allows you to do. Blas, I think I had, there was a comment in the chat that I saw.
Yes. The question was, what technology Petrobras used to capture the data? Sensors, ABB? So I'm not exactly sure if you can share it, but what was kind of their approach to this offshore?
I can't, sorry, yeah, I can't share it. I can't share it, right? But, you know, just want to say that from my window at the R&D center where I had my office, you know, I saw many of those platforms being engineered or doing maintenance, and you know, there were cities that floated. They had all these networks of technology, pipes, sensors, water valves, and gas valves and oil valves. I was just amazed with that. And of course, you know, all the technology was powered by a very mature OT technology, right? Operations technology. And what we are trying to execute is to bring more and more digital intelligence on top of that. So when I talk about IoT, IoT is not just Internet of Things, but in my opinion, IoT is the merger of OT and IT, right? That was the key difference over there, right? Most of your organizations have a very mature OT environment, right? With years of work with OSI Softy and SCADA. That's a lot of data, right? And the idea is that start by applying all those analytics techniques against that data, right? And correlate that with more sources of data that may come from IT, it may come from the business world, right? That can drive a lot of new insights to an oil business.
And just on that front, I just want to share kind of like my shameless way I'm trying to get my answers, get my questions answered, is that I usually get with when I represent some of the bigger clients, I usually get on the board with some of the sales teams of the providers of those solutions, and they usually can give me all the information that is needed, right? That if I ask them, oh, so but how do I deploy this? And they're like, oh, well, our clients did this, and so I think that like that knowledge of how to do things, probably the sales team will be your best ally on trying to understand how those things are done across the board, how they're done across the industry, and just use your sales team, because they will give you this data and they will give you this information to the extent they could. And that probably be the best source of information besides just trying to hire someone from that particular organization.
Perfect. All right, so let's get to the edge. The edge is the intersection between the physical and the virtual world. And the nice thing about the edge is this trend, right? That pretty soon, the amount of data being processed is going to be, you know, growing at the edge a lot faster than at the data center and the cloud. Why? Because we're going to be moving to a more real-time analytics world where the time and the resources necessary to move data to a consolidated place to analyze it, right, is not going to, you know, to be viable anymore to sustain the business model. So how is it going to happen? Well, this is the idea of the data model, right, and the outcome. So at the edge, you have the business events. The sensors are very close, right? So all the sensors are here close to the edge, and they communicate with your infrastructure at low latency, very fast, right? You're not traveling distances. The edge is deployed as close as possible to your business infrastructure. That means you're going to have a cloud-like data center, miniaturized, of course, ruggedized, of course, deployed at the oil station in the middle of the ocean, right? And this equipment is communicating at local speeds with all the sensors, the dozens of thousands and maybe hundreds of thousands of sensors that monitor the health of that smart platform, right? There's a digital model that explains your physical world, and it's being monitored just like a Formula One car has telemetry by your local data center. This local data center is able to apply the optimal models in real time against the sensor data and decide if things need to be adjusted, things need to be improved, things are deviating by some way from the optimal state. Then you have the core, then you have your data center. It's where you aggregate data. You look at the past, right? Your edge feeds your data center, your central data repository, right? Your data lake, better than the data warehouse, they're calling this the data lake, with the curated view of all the events past. And you are using this for data science. You're using this data lake with your data scientists to keep experimenting and improving the model, improving the predictions, and gaining insights. Those insights become changes to your applications that are then applied at the edge. So it's a cycle, right? It's a cycle. You take action at the edge, you fuel learning at the core, and what you learn as an insight becomes a better model at the edge. Why you need an edge? Laws of physics, distance, latency, right? And what do you do with this? You create what we call the virtuous cycle. Can start any point here in the curve, but I like to start with data, like I said. You get new data, you deliver new insights. You take that insight, you deploy as new software capabilities, you generate more data. And this virtual cycle is the digital transformation cycle. And moving that wheel fast is what makes organization becomes more and more digital. And in order for us to make this wheel move fast, what we need to gain more capabilities in software development, gain more capabilities in data analytics, build an organization that enables software and data to work together with all these elements I described during the conversation in the morning. The organizations that have done this, even in oil and gas or in other industries, right, that are not B2C exactly, they were able to apply this to reduce operational costs, become more profitable, and respond a lot faster to an ever-changing business environment. That's the key game. It's not easy. Partner with organizations that can help you, but own it. You know, it's about, you know, learning how to fish instead of buying for fish. Learn it, gain those skills, and have an organization that is able to leverage them. I still have a couple of minutes, Vlas, so I want to talk a little about, you know, the company I work for, Dell, and some ideas that we can use together to help you.
Please.
Right. So it's been 1 hour and 20 minutes of open environmental conversation. Now I need 10 minutes of propaganda. But what I wanted to do in the end is to invite you to continue this conversation, right? You started this conversation with the Silicon Valley Innovation Center. My job is to continue these conversations at Dell, and feel free to connect with me if you're interested, right? So the company is Dell Technologies, and it's a very big company in technology, one of the largest ones in IT, very innovative, driving over 90 billion a year of revenue, and still investing a lot in R&D because innovation is leader. We have a very broad portfolio of technology solutions, from PCs and laptops to data centers and virtualization technologies, software for the infrastructure, very well recognized. And from this foundation of strength, we build solutions that help drive digital transformation. Analysts like us, but when we put all the portfolio together, here is the marketecture, right? So I talked about it all today. This is what I talked about today, right? We talked about digital opportunities. Maybe I should have like an oil pump here too, right? But it's how you make ideas for, business transformation. This requires a different approach to technologies, right? Some of them are going to be new for your organization. Some of them are going to be cutting edge, but not necessarily, right? You may be incorporating AI, right? And next on your next digital project, you will be incorporating virtual reality, right? But anyway, just changing technologies is an enterprise by itself. Let's talk about the foundation, right? So like I said, all this software-driven transformation is going to be pushed by an infrastructure, sustained by an infrastructure. And this is what Dell Technologies does. Dell Technologies offers, through that portfolio that I showed, an environment where you can have infrastructure that is trusted, secure, available for cloud, data center, and edge use cases, and able to support your existing and future applications and data sets. We help unlock the value of data, right? So when I talked about looking for partners, we have a strong practice in helping organizations become more data-driven, right? We are very strong into finding those use cases and doing projects together. That's how we enable success. We have the ability to put that infrastructure to practice everywhere, right? So I talked about the oil stations and platforms, right? This is also a very interesting use case. So we deployed floating data centers with Mercy ships, taking medical aid to sub-Saharan Africa, right? And inside these ships, there's medical equipment, there is intense healthcare units, etc. And it takes a lot of IT systems to run it, right? We have a floating data center that we put inside this equipment, and as it's a boat, right? It rocks, right? And we have equipment that can be deployed in this kind of environment. Not your typical data center equipment, but compatible. I mean, your consumption of technology is the same, but your physical deployment, it's where you can run it everywhere, right? Just like your engineers, right? We have personal equipment, tablets and computers that your engineers can take to the desert, that can take to the Arctic, right? Can take everywhere and be productive and connected and work, right? While having a platform that resists, tolerates all this environment. Military grade equipment in many use cases. And finally, not only data and infrastructure, but also the act of adopting modern development software, right? We have a very strong practice into that. And when I was trying to find one interesting reference to bring, right? I think that the coolest one is this over here. This is Project Kessel Run from the United States Air Force, right? So I love this one because Kessel Run is a reference to Star Wars. If you are a fan like I am, right? I love references. And this is the Millennium Falcon. And basically, we help the United States Air Force adopt modern software techniques to transform how they did fueling planning at first, one of the key use cases. And now they're using it by themselves for other things that are classified, right? But the first use case was optimizing fueling logistics and enabling fighters to continue to operate in the air, right, with much faster decisions. They used to have a spreadsheet to manage this, right? So, okay, so this squadron is fueling next, and then it goes back to the action zone, or etc. And now they have an app for that, like pretty much in the Silicon Valley way, they have an app for that. And then, of course, that app is loaded in some means, right, on a F something, you know, maybe an F-15 or F-22 module, so the pilot can interact with that and get the directions for his plane in real time. So Kessel Run, you know, the reference, but the case is really cool. And finally, when you talk about organizational challenges, right, we talked about reorging, we talk about, you know, all these ideas of retooling the team. Well, we could do this for the military, right? There's nothing more hierarchical than a military organization. Last week, the news went out that we signed an agreement with Space Force, which is going to be way cooler. I'm expecting something like Star Trek, right? We had Star Wars with the United States Air Force. I'm expecting something like a Star Trek reference for Space Force. Data integration is another expertise and capability that we have that is very important. Why? Well, because, you know, your new capabilities are not going to exist out of the blue. They're going to connect with your existing systems that are still going to be around, sustaining your business for the next years, right? So data integration is something that we can help with that is also very important. And this is more for the IT roadmap. So, you know, like I said, I'd love to continue this conversation, and I'd love to meet your IT leaders, right? So we can talk about ideas for your future applications and deployment and how they live in a cloud. So all these buzzwords are cloud services, and how we transform the technology operational model from you know, sell to production at scale. So here's my invitation. Let's have a conversation, you know, just like we had this introduction over here, right? And if you like the ideas and you want to learn more about how Dell can do this, connect with me and let's talk, right? But meanwhile, enjoy the rest of the agenda, enjoy the program. You are in great hands with the Silicon Valley Innovation Center, and I hope you enjoy the rest of the program. Thank you very much for having me this morning.
Rodrigo, thank you so much for allocating your time today. I know it's only a double holiday. We definitely do appreciate you taking time and talking to us today.
Awesome. Thank you for having me. And I know that I'm on top of the hour here, but do you still have time for one last question or comment, Blas?
I think, well, if I don't see any questions. We had some questions throughout the program that we have answered, but I think we don't have like a follow-up questions yet.
Perfect. Okay.
All right.
Okay. All right. Thank you very much for having me. Enjoy the rest of the program.
Thank you. Thank you, Rodrigo. Thanks. Bye.
Bye-bye.